Chapter 4 review. Alright, gang, so the good news is after today we're only reviewing one more chapter and then we get to start learning some new stuff and slow down a little bit. But let's continue our review of Part A of this course with the Chapter 4 review. This chapter is mostly about graphing and graphs functions. So hopefully some of this is review and brought to memory. Some of it we will be diving deeper into next chapter and then a lot of the new stuff we're learning. So we'll be able to refresh on this chapter a lot going forward. Alright, so graphs. We can graph equations on the coordinate plane. And remember, a coordinate plane is something like this. So we have two sets of axes, one going vertical, one going horizontal. Remember, the y-axis is the vertical axis. The easy way to remember that is y to the sky. Then x is across. Okay, x is across. An ordered pair or coordinate can be written in the form of x comma y. So if we have a coordinate 1 comma 2, that tells us we're going to go in the x direction 1 and in the y direction 2, and that's where we're going to plot our point. So we're going to go across to the right 1 because it's positive and up 2 because it's positive. So when given a chart, table, or multiple ordered pairs, this is when you can begin to create a line or other graphs, which we will be getting into. Now we're going to talk about labeling your graph. So make sure that you understand when you're making a coordinate plane, you should always have arrows at the end of your lines because that tells us that the line continues going on and on forever. So that is pretty important. The other thing you want to do is make sure you label your axes. So we have y and x. We're going to zoom in on this coordinate here because it's the one we're going to use most in Algebra 1. We will use some of the other coordinates, but this quadrant, okay, see how the graph is separated into 4 parts? So we're going to call them quadrants. This quadrant here is called quadrant 1, right? And it's represented by the Roman numeral 1. So if we zoom in on that quadrant, we're going to see lots of graphs that look like this on the right. When we see a graph like this, we are going to label it with a title. What is this graph telling us? Well, in this graph, it's talking about board length. I'm not sure exactly what board length means, but that's what this graph is talking about, and maybe if you were giving a sentence or a paragraph or a word problem with it, you would understand the title a little better. Well, in the y direction, it is measuring length. Right? So you always want to label your axes when you're giving a graph, both with the y and the title of what it's measuring. And time is in the x direction. And usually time will come with parentheses here to say what you're measuring time in. Here you might use time in minutes, or if it's, you could use S for seconds. It is very important to label your graph. And with length, again, after the word length, you may want to put centimeters or inches or something along those lines. It also helps to create T-charts. And a T-chart is something that will help you give coordinates. So if you're given an equation and you have to plot that equation, you're always going to label one part of your T-graph X, and the other one is going to be your Y, or your equation. So in this case, it's going to be Y equals 3x plus 15. So I'm just going to start with 0. You can start with whatever number you like, but I'm going to start with 0. So if I plug 0 into our equation, then I'm going to get 3 times 0, which is 0, plus 15. So this side's going to give me 15. If I plug 1 in, I get 3 times 1, which is 1, plus 15, which is 18. If I plug 2 in, you'll see I'll get 21. 3 in, I'll get 24. You should start seeing a pattern in the right-hand column, in our y column, so that when we plot this, all right, in our x direction we have 1, 2, 3. In our y direction we have a lot. Right, and we're going to pretend each one of these dashes is 2, so on. So our first coordinate, x is 0, so it's going to be on this line, and it's 15, 2, 4, 6, 8, 10, 12, 14. So it's going to be on this line somewhere in between there. Sorry for my graph and lines bending. The next one is going to be at 1 and 18, which is going to be here. Next one's going to be at 2 and 21, which is going to be somewhere here. And you'll see if I drew this on graph paper, I would have a straight line like this. So that's how we can graph lines or other functions using a t-chart. A function is a graph that only has one value of y for each value of x. So something you may be asked is this graph a function? The easiest way to tell if a graph is a function is after you graph it. Okay, say I have some weird graph, it looks like this. Can we do a vertical line test? If we can do a vertical line test, then it is a function. And what a vertical line test does is, can I draw a vertical line anywhere on this graph? Does it only hit the graph once? So do my lines only hit the graph once? And in this case they do, so this graph is a function. So if we had a graph, and I'm just going to draw it real small down here, that kind of looked like that, well, if we did our vertical line test, we could see that possibly right here, that line would hit our graph twice, so this graph would not be a function. That's the simplest way to tell whether a graph is a function or not, is by graphing it if you're giving a chart, table, or ordered pair, or if you're already given the graph, doing the vertical line test. There are a few different types of graph that's helpful to know. Mostly in algebra we'll be dealing with linear graphs or linear functions. Alright, so that means that you're going to, when drawing or creating a graph, it's going to look like a straight line. There are other graphs that, when given maybe a chart or a table, when you're plotting points, you will see. You won't need to know necessarily what those graphs are, but they could look like these three here. And what these graphs are is if you have a square, something to the third power, or the absolute value, you would get graphs that look like this. You do not need to memorize that, just to know that you could see graphs like this if you're given a set of coordinate points. The last thing this chapter covers is arithmetic sequences. All right, and a sequence is just an ordered list of numbers that often forms a pattern. So if we're looking for a sequence in the other things, you will see patterns in the Y column. So if we want to try and find the pattern with the ones below, these are only dealing with arithmetic, so adding, subtracting, multiplying, and dividing. So if we look at A, we can try and see a pattern here. Does anybody see the pattern? Hopefully, you could see that between each one of these, you're adding 6. So the next one in this pattern would be 29. For B, I'm going to give you a second or two. See if you can figure out this pattern. Did you say that each one you divide by 2? So you're dividing by 2 each step. So the next one in this pattern should be 25. How about C? So a little trick here is, if the signs are alternating, what causes alternating signs? Well, if signs are alternating, you're probably multiplying by a negative number or dividing by a negative number. So in this case, you can see that they're probably multiplying by -2. So if I multiply by -2 each step, then the next step answer in the pattern should just be 32. Finally here, the pattern is increasing from smallest to largest. So anytime it's increasing, you want to think addition or multiplication. So we got to see if we can see a common pattern. Here we can see it just increases by 4 every time. So the next one in this pattern, -3 plus 4, would give me 1. That's what Chapter 4 discusses. We will have more time as we learn our new material to review this stuff. If you have any questions, please ask them. Good luck with the Check Your Understanding. And again, if you have questions with that, please ask.